Hey there, future scientists. Have you ever looked up at the big, beautiful sky and wondered, why is it blue? I mean, we see it almost every day, right? It feels like one of those things we should just know. But the science behind it is actually pretty amazing. And what about sunsets? Why does the sky suddenly switch it up and turn into this incredible canvas of red and orange? Well, today we're going to answer both of those questions. It turns out the secret is all about how sunlight and our planet's air have a little dance together. Stick around, because this is one of those explanations that will change how you see the world every single day. First things first, let's talk about sunlight. When you look at the sun, don't look directly at it, by the way. The light appears white, or maybe a little yellowish. But that white light is a bit of a magic trick. It's actually a super mix of all the colors of the rainbow, all blended together. Think about it like a painter's palette, where someone has swirled all the colors together to get white. Inside that single beam of sunlight, you've got red, orange, yellow, green, blue, and violet. They're all traveling together, just waiting for something to come along and split them apart. It's like a secret rainbow hidden in plain sight, and Earth's atmosphere is the key to unlocking it. You might have seen this effect if you've ever shone a light through a crystal or a prism. Our sky does something very similar, but on a much, much bigger scale. So, we've got our sunlight, packed with all its colors, hurtling through space. Then, it hits Earth's atmosphere. Now, what is the atmosphere? It's basically a giant ocean of air surrounding our planet, made up of teeny tiny invisible molecules of gases like nitrogen and oxygen, plus little bits of dust and water vapor. When that beam of sunlight enters the atmosphere, it starts bumping into all these tiny particles. Imagine trying to run in a straight line through a really crowded room. You're going to bump into people and get knocked off course. That's exactly what happens to the light. But here's the crucial part. The air molecules in the atmosphere do untreat all the colors of light the same way. They play favorites, and the color they mess with the most is blue. This is where the magic really happens. This phenomenon is called Rayleigh scattering, named after the scientist who figured it out. Here's the deal. Different colors of light travel in waves, and each color has a different wavelength. Red and orange light have long, stretched-out wavelengths. Because the blue light waves are so short and energetic, they are much more likely to hit the tiny air molecules and get scattered. When we say scattered, we mean they get bounced off in every possible direction, up, down, sideways, you name it. The longer wavelengths of red and orange light are more likely to just cruise right on through the atmosphere in a relatively straight line without getting bothered as much. So you can picture the blue light getting thrown around like confetti all over the sky, while the red light marches on more directly. Because that blue light is being scattered everywhere. It seems to come at us from all parts of the sky. No matter where you look, as long as you not looking right at the sun, some of that scattered blue light is traveling from that direction and entering your eyes. It's not that the air itself is blue. The air is acting like a massive planet-sized filter that intercepts sunlight and rebroadcasts the blue part in every direction. The violet light gets scattered even more than the blue, but our eyes are just more sensitive to blue, and there's more blue light in the sun's spectrum to begin with, so blue wins the day. Alright, that covers the daytime. But now for the grand finale, the sunset. Why does our beautiful blue sky transform into a spectacular show of reds, oranges, and pinks? It comes back to the same principle of scattering, but with a twist. At midday, the sun is high overhead, and its light travels through a relatively thin layer of atmosphere to reach you. But as the sun sets, it gets lower and lower on the horizon. It's like the difference between swimming straight down to the bottom of a shallow pool versus swimming the entire length of it. At sunset, the light is taking the long route because the sunlight is passing through so much more air. That means there are way more air molecules for it to interact with. There's more scattering happening. A lot more. By the time the light from the setting sun reaches you, almost all of the short wavelength blue and violet light has been scattered away from your direct line of sight. It's been bounced off in other directions long before it ever gets to you. You guessed it, the longer wavelengths of red, orange, and yellow light. These colors make it through more directly, and that's what we see. The sky and the clouds near the horizon get illuminated by this remaining reddish-orange light, creating the breathtaking colors of a sunset. It's like nature is slowly turning down the blue light filter and cranking up the red and orange channels for a spectacular evening show. So let's do a quick recap to lock it in. Sunlight, which looks white, is really a mix of all colors. When this light enters our atmosphere, the tiny air molecules scatter the short wavelength blue light in all directions. Our eyes see this scattered light coming from everywhere, making the daytime sky appear blue. Then, at sunset or sunrise, the sun is low on the horizon, and its light has to travel through much more atmosphere to reach us. During this long journey, most of the blue light is scattered away. This leaves the longer wavelengths of red and orange light to come through to our eyes, painting the sky in those warm, fiery colors. It's a simple, elegant piece of physics that creates one of the most universally beautiful sights we get to experience. Every single day, you're witnessing Rayleigh scattering on a planetary scale. How cool is that? The next time you're outside, take a moment to look up and really appreciate what's going on. You're not just seeing a color. You re-seeing the result of a beautiful interaction between starlight and our own planet's protective blanket of air. It's a constant reminder of the incredible science that's happening all around us all the time. And now you know exactly how it works. If your brain enjoys getting these simple, clear explanations for some of life's biggest questions, we'd love it if you'd hit that like button and subscribe to the channel. We have so many more mysteries to unravel together. Coming up next, we're tackling the sound and fury of a storm. What really causes thunder and lightning? Thanks for watching, and stay curious.